Good day to you all. We're talking about integers today, and integers, you can see by the quick definition that I have here. I don't know if you can see that. I might need to stay out of the way here. But integers is a set of whole numbers and their opposites. We're talking about positives and negatives in this unit. And we talk about the rough basics as they relate to integers so we can get you guys ready for some of the more complex operations in the 7th and 8th grade. Take a pause whenever you need to copy notes. I'm going to move on as soon as I move on. Here we go. And if we take a look right here, we see that we have a little Frayer model. It has a lot of useful information on it. It has a nice definition. It has a couple of interesting facts. It has some nice examples, and it has some nice non-examples as well. These are things that are not integers. These are things that are integers. So take a moment to soak this in, write down stuff, and take some nice notes. Okay, we're going to move on from here. Take this down here. And maybe we'll try to apply some of those skills of integers. We've had a little experience so far, hopefully. You may have seen this in some previous classes, maybe some earlier elementary courses. And I want to know from you, what is the opposite of a negative integer? Hopefully you're saying it's a positive integer. What's the opposite of a positive integer? It's a negative integer. So the opposite of a negative 7 would then have to be positive 7. And the opposite of a positive 8 would have to be negative 8. The opposite of 0 would be, well, it's actually, there's no opposite of 0. It's just going to be 0. If you want to put a little NA for not applicable, that's fine. 0 is just 0. 0 is not positive. 0 is not negative. It's just 0. Think about 0 as being the dividing point between positive integers and negative integers. Another very valuable topic in integers is the concept of absolute value. Absolute value is the distance from 0 on a number line, and it can be easily calculated or easily discovered just by using a number line. And I have an example right here. Hopefully you can see that. Let me take a quick look to see if you can actually see that. Of course you can see that. That should be just fine. What is the absolute value of negative 7? Well, if it's just the absolute value or the distance from 0 on a number line, a good first step might be to actually graph negative 7. And I have a number line here. I have 0 as my kind of frame of reference there. And if I look to the left of 0, which is where negative integers live, I can see that this is 1, 2, 3, 4, 5, 6, 7. It's the seventh place before 0. So I'm going to call this negative 7. Put a little mark there. And I can then figure out how many moves it takes to get to 0 from negative 7. So it'll be 1, 2, 3, 4, 5, 6, and 7. It takes 7 moves, so my answer will just be 7. You might notice that the numbers are the same. It's almost like I just took off the negative sign. What's the absolute value of positive 3 then? Like I said, it might be a good idea to start by graphing that number. So here's positive 3. And if I move 3 places, 1, 2, 3, I end up at 0, my answer should be 0. Should be 3. Ugh. It should be 3. So the absolute value of 3 is 3 because it is 3 places from 0. The absolute value of negative 7 is 7 because it is 7 units from 0. That's all it is. Very easy. Think about it as whatever's inside the absolute value brackets, whatever has to come out has to be positive. Let's move on. The beauty of a video is that you can stop whenever you want to. You might notice that I haven't dropped any boards on myself so far. High five. We have 2 other skills that I want to make sure that we are pretty clear on, and those are comparing integers and ordering integers. We have right here and right here. When we are comparing integers, I want you to remember that when I use a number line to compare things, when I go to the left, things get less and less and less in value, smaller and smaller in value. As I go to the right, they get bigger and bigger in value. So when I am putting them on a number line, whichever value is to the right is going to be the bigger value, whichever is to the left is going to be the lesser value. I have a few examples here, and I have a few that you could try yourself at home. So these are the home examples. Try those out yourself. You have a home example here as well. And my question to you, and you might want to take a pause here and actually jot them down, try them yourself, because I'm going to solve them right away. What is the symbol that I can place in here, the inequality symbol, that will make this statement true? It is 8 blank negative 8. I would place in there a greater than, because positive 8 is greater than negative 8. And as a rule, anything that's positive is always greater than anything that is negative. If I scroll over here, negative 3 blank positive 1, again, that same rule still applies. A negative is always going to be less than a positive, so negative 3 is going to be less than a positive 1. And I also tell my students this. Think about this in terms of money. Would you rather owe somebody $3 or have $1? I think we're all going to agree it's better to have $1 than to owe $3. So the greater value is going to be the positive 1. The mouth always goes to the greater value. The mouth always goes to the greater value. Negative 1 blank negative 4. Think about that real life scenario again. Is it better to owe $1 or to owe $4? It's better to owe $1 than to owe $4. So negative 1 is going to be a greater value. It's closer to 0. And also if you graph it onto a number line, you're going to see that negative 1 is to the right of negative 4. 0 and negative 2. 0 actually, even though it doesn't have any value, is a greater value than negative 2, even if you only think of it in terms of the real life scenario. Is it better to have no money or to owe somebody $2? I think it's better to have no money than to owe somebody $2. That's going to be a greater value. It's the value that is further to the right. Here's a couple of homework problems for you. If you're doing this right now, it might be a good idea to try those out, see if you're correct. And if you ask me in class, I'd be happy to correct those and discuss those with you. When we order integers, we're doing very much the same thing as this, but instead of only dealing with 2 numbers, we're dealing usually with several. So that they might be negative and positive integers. They might be all negatives. They might be all positives. But all in all, we have to put things in order according to whatever the directions say. It's going to be either least to greatest or greatest to least. And in this example here, we have we're trying to find the least to greatest order of positive 2, negative 3, positive 4, negative 6, 0, and negative 1. Again, if I use a number line, I can easily order these. And I'm going to draw a really quick one somewhere. I'll draw it right here. It may not be very easy to see. You might need to maximize the window. But I'm going to graph all of these points. I'm going to start with my 0 because it's a great place to start writing numbers to the left and to the right of that. And I see that I have a couple of positives in there, so I'm going to have enough spaces for them. So I know that this looks a little bit busy right now, but once I put my numbers in, it's going to look a little easier to see. I have a positive 2, so that's going to go 2 units to the right of 0. I have a negative 3, which is going to go 3 units to the left of 0. I have a positive 4. I have a negative 6. And I have a 0, which is already there, and I have a negative 1. Guess what? My answer is right there. Negative 6, negative 3, negative 1, 0, 2, and 4. It's in order because a number line is also in order from least to greatest. So it's a nice little trick to putting things in order. Instead of having to put them in order, you're actually just graphing them, and you're doing 2 jobs in one. For greatest to least, it's not the same exact thing. However, you can use a number line for this if you wish. You just have to read the answer backwards. I want to think about this as in a real life situation. I want to think about the whole money thing again. I want to say to myself, what is the best situation to have out of all of these? Is it best to owe $5, to have $8, to have $6, to have $1, to owe $7, or to have $4? I think it's the best to have $8. So I'm going to call that my greatest value. Okay. My next biggest value is going to be 6. My next biggest value after that is going to be 4, followed by 1. And then I have my 2 negative numbers, and I need to make a decision. Which one of them is a better situation to be in? Owing $5 or owing $7? And I would have to say that owing $5 is a better situation to be in than owing $7. Sorry about that sloppiness. It's kind of hard to write in the bottom of the board. And that's it. So you have a couple different strategies on ordering and comparing things. You can think about money. You can think about using a number line. You can use a little bit of common sense. And I think this is going to be one of the easier things that we can get through. But it's going to be a great way to get you ready for next year's math courses and using integers in a more intelligent way. So. Yeah, please. Yeah, I'm videoing right now.
Oh,
okay. Alrighty, folks. If you have any questions, please make sure to bring those comments to class with you. We'll be quizzing this fairly quickly because this is one of the lighter SOLs, but this is going to come up a lot in the next few SOL. So make sure that you are pretty comfortable with it, and I'll see you in class.